Welcome to Homework Lib.
Hi, so over here we want to know which of the different structures for B2E is an isomer and which one of them are resonance structures of anion A. So first of all, let's remember that a resonance structure can be found directly from the resonance species starting from compound A. So we would need to be able to achieve that conformation by moving around electrons. So in order to do that, let's begin by generating one of the compounds. In the first step, I'm going to go ahead and generate compound C directly because I know that that needs to be a pair of electrons here with a negative charge. This one needs to be one of the resonance contributors. So what we're going to do here is take this pair of electrons over this carbon, then this pair of electrons goes to this position, this pair over here, and finally a pair of electrons goes towards the oxygen atom. After this consideration, what is going to happen is that we're going to generate the following compound, which is double bond here, single bond, sorry about that, oxygen with a negative charge, double bond here, just for completion on this side, and a double bond in this position. As you can see, C is going to be a resonance structure, so I'm going to label it directly as R. Now, what are the other possibilities that we can achieve starting from this contribution? Well, actually, I can go ahead and start moving around electrons over here from my oxygen atom. I can return this pair of electrons to generate a double bond, and now I can take this pair of electrons and attach them to my carbon atom. What that is going to generate is the following structure. Let's go ahead and draw again our benzene ring. Oops. We're going to recover the double bond. Over here, the double bond stays the same. Down here, the same thing. But now we're going to have a pair of electrons with a negative charge attached to it at this position. So this is compound E. And as you can see, it can be generated as a resonance contribution from my initial compound. Now, if I wanted to generate another contribution, what would need to happen is that the pair of electrons can go back here to generate the double bond. And now the carbon atom that is right here at the center, let me clean up this structure a little bit just to make this more clear. Down here we had, oops, with black. Double bond and a single bond. When we take this pair of electrons to generate a double bond and attach them now to this carbon atom, now the anion is going to be in this position. Pair of atoms, negative charge, and the double bond that resides would be in this position. So those are the possible resonance structures that we can have. With this, we can safely say that we cannot generate compound D. Now let's go ahead and try to generate compound B in this case, and for that to happen, I would need to start again from one of the contributions of my oxygen atom, and there is no way for me to generate that structure. So B and D are going to be isomers, and C and E are going to be resonance structures of A. That would be all. Thank you very much, and have a good one.